Every beam of starlight carries a message from the past, traveling through space and time to reach us. Today, we'll explore how galaxies hold memories of their ancient history, written in light, chemistry, and cosmic patterns. Light from stars takes an amazing journey before reaching our eyes. When you look at the Andromeda Galaxy, you're seeing light that left those stars 2.5 million years ago. That means we're watching Andromeda's past, when early humans were just beginning to use stone tools on Earth. Think of starlight like a cosmic time capsule. Each photon of light carries information about the star's temperature, chemical makeup, and motion from the moment it started its journey. When astronomers study this ancient light, they can figure out what stars were like millions or even billions of years ago. It's like having a window into different moments in cosmic history, all visible in tonight's sky. The stars we see might not even exist anymore. We're just seeing their light from long ago still traveling through space. Stars are like cosmic time capsules, each one carrying chemical clues about their birth and life story. When we look at a star's light through special tools called spectrographs, we can see dark lines that tell us which chemical elements are present. It's similar to how each person has unique fingerprints. Every star has its own chemical signature. Older stars tend to have fewer heavy elements, while younger stars are rich in metals made by previous generations of stars. By studying these patterns, astronomers can tell if a star formed early in the universe's history or more recently. The oldest stars we've found are made almost entirely of hydrogen and helium, the original elements from the Big Bang. Younger stars contain more complex elements like iron, carbon, and oxygen, showing us how the universe gradually created new chemical elements over billions of years. Dark matter halos are like invisible scaffolding that surrounds galaxies, and they hold important clues about how galaxies formed. While we can't see dark matter directly, we can detect its effects through gravity. These halos act like a galaxy's memory bank, preserving information about its earliest days. The way stars and gas move within a galaxy tells us about the dark matter's shape and size. Scientists have found that bigger galaxies tend to have larger dark matter halos like a cosmic-sized chart. When galaxies crash into each other, their dark matter halos mix together but keep a record of these ancient collisions. By mapping these halos, astronomers can trace how galaxies grew over billions of years, similar to reading a family tree. It's fascinating that something we can't see holds so many secrets about our cosmic history. Just like tree rings tell us about Earth's past, stars have their own way of revealing their age. When astronomers study a star, they look at three main features: its brightness, color, and the way it shakes or vibrates. These stellar properties work like a cosmic birth certificate. Bright blue stars are usually young and energetic, while dimmer red stars tend to be older and cooler. The star's core also gives away its age. As stars get older, they convert hydrogen into helium, changing their internal structure. By measuring tiny vibrations on the star's surface, scientists can peek inside to see how much hydrogen is left, like checking the fuel gauge in a car. Some stars we've found are nearly as old as the universe itself, around 13 billion years old. These ancient stars are helping us understand what the early universe was like. When massive stars die, they don't just disappear. They leave behind powerful remnants that continue shaping their galaxies. These cosmic ghosts come in different forms: super-dense neutron stars, mysterious black holes, and beautiful nebulas made of star stuff. A single neutron star, though only about 12 miles wide, can have more mass than our Sun. These remnants act like cosmic lighthouses, sending out radiation and energy that affects nearby gas and dust. Black holes are even more dramatic. They create huge zones of influence, pulling in material and heating it up so hot it glows brightly. The leftover gas from dead stars also helps form new stars, like cosmic recycling. In fact, many of the elements in our own bodies came from ancient stars that exploded long ago. These stellar ghosts show us that even after death, stars continue playing important roles in their galaxies. When galaxies crash into each other, they leave lasting marks that astronomers can spot millions of years later. These cosmic collisions create beautiful streams of stars that look like ribbons in space, stretching out for thousands of light years. The stars, gas, and dust get pulled into new shapes by gravity, like cosmic taffy being stretched. Sometimes the crash creates bursts of new star formation, lighting up the galaxies like fireworks. Our own Milky Way still shows signs of past mergers. We can see warps in its disk and streams of stars that came from smaller galaxies it absorbed. Even the unusual positions and movements of some star clusters tell us about ancient collisions. It's like cosmic detective work, where astronomers piece together clues about these dramatic events from long ago. Stars are like a galaxy's history book, with each new generation telling us how that galaxy changed over time. When we look at star-forming regions, we see cosmic nurseries where gas and dust clump together to make new stars. The rate at which stars form gives us big clues about a galaxy's past. For example, some galaxies had huge bursts of star formation long ago, while others created stars at a slower, steadier pace. We can tell this by looking at the different ages and types of stars present today. Young stars appear bright blue and often cluster together in spiral arms, while older stars spread out more evenly and look redder. The chemicals in these stars also tell a story. Newer stars contain more complex elements that could only have come from previous generations of stars that exploded. The way stars move through galaxies is like a cosmic dance that remembers the past. When we track how stars orbit in our galaxy, we're seeing patterns that formed billions of years ago. Stars that move together in groups often came from the same origin. Maybe a cluster that broke apart or a smaller galaxy that our Milky Way absorbed. Some stars follow strange paths, moving in the opposite direction to most others or swinging far above and below the galaxy's main disk. These odd orbits are clues that point to ancient events, like when our galaxy merged with smaller ones. By mapping these stellar movements, astronomers can work backward in time, almost like rewinding a video, to understand how our galaxy grew and changed. Think of it as reading the Milky Way's diary, written in the endless loops and paths of billions of stars. The universe has an amazing network called the cosmic web, connecting galaxies like a giant 3D spider web made of invisible dark matter threads. These threads guide how galaxies move and grow, creating paths that have existed since the early universe. When we map thousands of galaxies, we see they're not scattered randomly. They follow these ancient paths like cosmic highways. The biggest collections of galaxies form at points where multiple threads cross, similar to how cities grow at major road intersections. This pattern has been in place for billions of years, showing us how the universe organized itself from the very beginning. The really cool part is that galaxies remember their place in this web through gravity, which keeps them moving along these invisible tracks through space. Let's fast forward millions of years and imagine future astronomers studying our current galaxy. The cosmic events happening right now will leave clues for them to discover. The Sagittarius dwarf galaxy is currently being pulled apart by our Milky Way. Future scientists will see the stretched-out star streams this creates. The supermassive black hole at our galaxy's center is having a quiet meal today, but the radiation from its snack will travel through space for millions of years. Even the new stars forming in the Orion Nebula will become part of the fossil record of our galaxy. The light from today's supernovas will keep traveling outward, carrying news of these cosmic explosions to distant future observers. It's amazing to think that the galaxy is constantly writing its own history book in starlight. Thanks for joining me on this cosmic journey through space and time. Every star tells a story, and there's so much more to explore. If you enjoyed learning about our universe's memories, hit like and subscribe for more space adventures.